Alright, this video is to help you get started with F01. So these are problems exactly the way that you will see them in ALEKS. So question 1 says, find the exact value of tangent negative 75. So anytime a problem says exact, it means no calculator. So we need to figure out how to express negative 75 using our 30, 60, 90 or 45, 45, 90 angles, because those we can use our special right triangles to evaluate. So let's think about how we can write negative 75. So we need to use either a 30, a 45, 90, 60, or some increment of one of those. So what if we took 120, so that's an increment of 60, and actually a negative 160 and a positive 45. What does that do for us? 120 minus 45. Let's see. That gives us 75. Sorry, that took longer than it should have. I promise my mental math will be a little faster next time. So we know that we can solve for these angles, 45 and 120, because they're derivatives of our 60 and 45, 45, 90. So tangent, we are looking for the tangent of 45 minus 120. So we are going to use this formula here. A is going to be 45 and B will be 120. So we're going to have the tangent of 45 minus the tangent of 120 divided by 1 plus tangent 45 times tangent 120. Well, tangent 45, we're going to use our 45, 45, 90 triangle. So we know that that has sides of 1, 1, and square root of 2. So tangent is opposite over adjacent. So tangent of 45 is 1. Tangent of 45 equals 1. Now, tangent of 120. Let's think about where 120 is on the unit circle. We know that that falls into the second quadrant. That's 120, which leaves us a 60-degree reference angle. Remember your 30, 60, 90. Opposite the 60 is root 3. Opposite the 30 is 1. And opposite 90 is 2. And in the second quadrant, tangent is negative. Remember, in the second quadrant, only sine and cosecant are positive. So we know that that's going to be a negative value. So tangent of 60, opposite over adjacent, is square root of 3, but we know that it's negative. So negative square root 3. So now we're just going to write that in, because we know what this is and we know what this is now. So 1 minus root 3 over 1 plus 1 times root 3, which is root 3. Okay. So in the next problem, we are asked to prove an identity. So proving trigonometric identities of problem type 1. So there are a couple of steps that you should always think about when trying to prove trig identities, or even to simplifying trig identities. Always look for any possible substitutions, especially if you have a 1 and something squared. Think about your Pythagorean identities. So always look for direct substitution when possible. Look for factoring. Rewrite in terms of sine and cosine. And add fractions. Those are 4 things that will almost always get you there. And then if those don't work, that one last thing to identify is if you have something like, say, a 1 plus a cosine theta, consider multiplying by the opposite of that, which is 1 minus cosine of theta, or similarly 1 plus tangent theta or 1 plus sine theta, because this will help get you to one of your Pythagorean identities potentially. Okay, so prove the identity that we have here, tangent x times cosecant squared x minus 1. Couple of different approaches. You could start with substituting tan with sine and cosine, or you could start by substituting cosecant squared x minus 1. Both are correct. So we'll go ahead and follow Alex's process. They went ahead and substituted tangent with sine over cosine. So tangent is sine x over cosine x, and that is your quotient identity for tangent. And cosecant squared x minus 1. Let's go and look at our Pythagorean identity. So see here, this is the one that has a cosecant squared in it. So when you rearrange that, cosecant squared u minus 1, that's equal to cotangent squared u. So we're going to substitute that whole thing with cotangent squared x. And that reason is Pythagorean identity. So cotangent is equal to cosine over sine. So that can be written as cosine squared x over sine squared x. And that reason is a quotient for cotangent. And now we can do some simplifying. So cosine x goes into cosine squared x, cosine x. And then we can simplify here. We've got sine goes into sine squared x, and that gives us just a sine x. And that's just algebra. And we're done. That gives us cotangent x. Okay. Next problem, same idea, complete the proof. Oh, that's one we just did, sorry. Prove the identity secant x minus cosine x. So again, those first ideas, substitution when possible, things in terms of sine and cosine. I don't have any squared terms, so I know I'm not going to start with my Pythagorean identity. So let's go ahead and write things in terms of sine and cosine. So secant is 1 over cosine x minus cosine x. So the reason for that would be reciprocal identity for secant. So right there, reciprocal identity for secant. So again, thinking about those steps that I just talked about, we've got substitution, adding fractions, factoring. So in this case, we see that we have a fraction. So let's go ahead and add it. So a common denominator is cosine x. So that's going to give us, we're going to multiply this by cosine x by cosine x. So that's going to give us 1 minus cosine squared x over cosine x. So again, every time you see a 1 and a cosine squared or a tangent squared or a secant squared, just a 1 and something squared, always go back and look at your identities and see, is there something here I can substitute? So we have the one that has a cosine and a 1. So that's this one. 1 minus cosine squared x is sine squared x. So that's going to give us sine squared x then, and the reason for substituting that is Pythagorean identity over cosine x. And if I break out the sine x, rewrite it kind of in expanded form, you can see, and that reason is algebra, but you can see that sine over cosine is tangent, so then we have sine x times tangent x. And that last replacement is your quotient property for tangent. Okay, so on this next one, prove the identity. So I don't have anything I can rewrite in terms of sine and cosine. I don't have anything squared to substitute. I don't have anything that I can factor. So remember I talked about it up here. When you have this 1 minus cosine x, consider multiplying by the opposite of that to see if it helps you out. So I'm going to multiply by 1 cosine x over 1 plus cosine x. That's allowed because it's the equivalent of multiplying by 1. So I'm not changing the value of anything if I'm multiplying by the equivalent of 1. And that's algebra. There's no trig function to define that. It's just algebra. Okay, so I'm going to multiply that out. So that's going to give me sine x cosine x plus sine x over, this is actually the difference of perfect squares. So if I were to use FOIL, I would get 1 minus cosine squared x. Because 1 times 1 is 1. Positive cosine x, negative cosine x goes to 0. And then cosine x times negative cosine x is negative cosine squared x. And I actually should have just left this as sine x times cosine x plus 1. Okay. So now we can see that 1 minus cosine squared x, we've got a 1 and a squared trig function, so we know Pythagorean identity, that's equal to sine squared x. So that's going to give me, I've got a sine x over sine squared x, so I can simplify this to cosine x plus 1 all over sine x. And now I can separate this fraction, cosine x over sine x, plus 1 over sine x. So cosine over sine is cotangent, quotient identity, plus 1 over sine, cosecant, reciprocal identity. And there we go, we've proven it. All right, proving identities using odd and even properties. So odd and even properties, that's where we're looking at our unit circle. And thinking about where are these angles positive and negative. So in this fourth quadrant, if we had a negative theta, let me go there first. If we had a negative theta, that just means we move this direction. So theta, we're thinking about theta in the fourth quadrant. So remember our unit circle, all students take calculus. Everything's positive here, only sine and cosecant here, tangent and cotangent are positive here, and cosine and secant are positive here. So cosine of negative theta can still be expressed as positive cosine of theta because it's in the fourth quadrant, and cosine's positive in the fourth quadrant. And secant of negative theta can still be expressed as positive secant theta. Because again, cosine and secant are both positive in the fourth quadrant. Any other trig function, let's say sine of negative theta. If we want to write that without a negative theta, we just know that, okay, our reference angle is theta in the fourth quadrant, but it has to be negative. So it just gets replaced with negative sine of theta. All right, so when dealing with these even and odd properties, we are literally just substituting in those identities. So for this first example, 1 minus cosine negative x, well, we know that cosine negative x is the same as positive cosine x, so that's just 1 minus cosine x. Secant of negative x, again, secant in the fourth quadrant is also positive, so that's secant x minus 1. So we still need to prove that that is equal to cosine x. So there are a couple of approaches we could take, but we could go ahead and rewrite this denominator in terms of sine and cosine, or in this case cosine. So that's 1 minus cosine x over 1 over cosine x minus 1. Common denominator for the denominator. Wow, that's a lot of denominators. So cosine x that gets a cosine x. So now we have 1 minus cosine x divided by 1 minus cosine x over cosine x, or multiplied by cosine x over 1 minus cosine x. And yay, algebra, that reduces to 1, and we're left with just cosine x. Okay. Prove the identity. These are sum and difference properties. And again, you have your full-on nifty little formulas for those. So actually, the one that we need is right here. It says prove the identity cosine x minus y plus cosine x plus y equals 2 cosine x cosine y. This is literally just substitution. So cosine x minus y, there's the identity we're going to use for that. So we're just going to substitute in. We're going to expand this first. So that's going to give us cosine x cosine y plus sine x sine y. And now cosine x plus y, we're going to use this identity. So that's going to give us plus cosine x cosine y minus sine x sine y. So we have two of those. And these two right here, go to 0. So that's 2 cosine x cosine y. And you can, when you expand that, your reason is sum and difference, and then algebra. Okay, I hope that helps get you moving on some of these problems. Actually, I just want to go through one more. This is use the sum or difference formula. So you just want to look at your formulas and say, okay, which one matches this? I've got a tangent, a minus, and a tangent. So that's this one right here. That's A, and that's B. So that is tangent of A minus B. So tangent of A minus B, so that's tangent of 78 minus 48. And 78 minus 48 is 30. So that's tangent of 30. So again, that's one of our special right triangles. We knew that it was going to be that because anytime the problem says exact, it's telling you no calculator. So let's find our tangent of our 30-degree angle here. Opposite 30 is 1, opposite 60 is root 3. Tangent is opposite over adjacent. So that's 1 over square root of 3. Or if we rationalize the denominator, we would multiply by root 3 over 3, root 3, which gives us root 3 over 3.